right now with my algebra student, we've been working a lot with, you have your line segment, your number line, you've got negative whatever to 0 or 1 to whatever, and it gives you like x is greater than or equal to 2, and you, whether it has the equal to, you draw the full circle or the open circle. Do you connect the line between the two? Do you just go 1 to 1 and leave the dots there? That's what I was trying to lead them to.
Yes, and that's a great discussion in just one dimension, one variable. Okay. Very good. Okay, next one. Sean, I think it's your group.
Oh, is it? Let's see. One second. Can everybody see this down here, or do I need to scoot it up?
I can see it. It's probably okay.
Alright.
You can scoot it up if you choose.
Your body's in the way.
I will do my best to make my body out of the way.
Okay.
Left my laser pointer, I'll just stand here. Alright, so the one that we had was number 8, and when we first asked about which ones, the first thing we did is we wanted to know, well, which ones do you want to know where they're shaded, and she gave us the option of choosing all of them, the red ones and blue ones. So the first ones we picked is we picked to figure out how to know how many blue squares are going to be in each one. So
Okay, I'll stop right there.
Yes,
They chose the red, and they chose the blue. So as they're talking, let's compare the difference in the functions and all, okay? Go ahead.
So, and I'm going to restart out of the way before I step on the rocks and do absolutely no damage to them. Alright, so the first thing we did is we made our table here. We based it off of the different shapes that we had, so we called them shapes. I believe that's what we did, yeah. So we have shape 1, shape 2, shape 3, and shape 4. So in shape 1, there is 5 blue squares. In shape 2, there are 9 blue squares. Shape 3 has 13 blue squares. Shape 4 has 17 blue squares. And then going by the pattern that our blue squares increased by, we went ahead and we made, if there was a 5th shape, going by the pattern that we've already figured out, it would be 21 squares. And we didn't jot it down on here, but our pattern that we discovered was that it increases, the number of blue squares increases by 4 each time.
And he caught himself. He first said it increases, caught himself and said the number of blue, which is perfect. Thank you.
Sorry. So after we did this, we then went over here and we made our graph, and we did connect our line just because I think we thought that would work out. I think we connected our line because we ended up going more into less of just keeping with only the concrete representation of it. We actually also kind of took it into an abstract thing. That's why at the top of the table here you see that we have the shape 0, blue 1. That was kind of a way we used to check and see and make our function work.
So they backed it up, okay? The x values are increasing by 1, so they decreased it by 1. The y values are increasing by 4, so they decreased it by 4. So they have an ordered pair 0, 1.
Yeah, the reason we did this, and this is something that I was explaining to them because it's something that I kind of explained to my kids. So if you go between each one of these, it increases by 4 each time. Usually what you're going to have happen, and I think Zarik did this the first time, you figure out, okay, how do I go from 1 to 5? Well, you can just add 4, or you can multiply 1 times 5. Either one of those will end up with the same result of being 5. This tells you how much it's going to go up each time. If you figure out how you go from your first one to your kind of hypothetical 0, you'll actually figure out that it goes down by 1, or down by 4. This then becomes your modifier, your little added on thing. So if you look on all the different functions that everybody has, every single person has one that has +1, -1, or whatever, some sort of addition or subtraction modifier. This is what will ultimately give you this little guy right here. Once you figure that out, then you just have to find
Wait,
out how
what
to...
little guy? What does that little guy say?
This little guy.
What does it say?
That's a +1 on mine. I said just little guy because...
Read the whole
Other people
guy. Read the whole thing to us.
Okay, well, I was just referring to this one portion of the function, but the function we ultimately came up with, and we used f of x as the function, because...
That's what we did.
Drew does algebra, so we went ahead and went that route. So the f of x is equal to 4x, or 4 multiplied by x plus 1. So 4x plus 1. The little guy that I was referring to was the +1 here, which is your little modifier there. That is what happens, this is what takes it away from being a proportional one, and one of the reasons
You
why.
don't go there.
Yeah, we don't need to
Don't
go
go
into the proportion.
Well, I want to later.
Okay.
So that, the little guy, the +1, where is that in your table?
In the table, the +1, I'm not really sure what in the table. I mean, this goes up by 1 each time, but
Okay,
If you want
think
to
about
consider that
that, because I'm
+1.
gonna come back to you
sure.
and ask you where the +1 is in your
Oh, yeah.
table. 0.
That's a 0. Okay.
I
Okay?
have one question real fast before I get too far, but did you say that that was shape 0?
Yes.
shape 0.
Yes, because like one of the first things I said is I said we kind of took it more into an abstract thing instead of just sticking with the concrete part. Because if you go, this would be just, if we're just looking, like you said before, you can't have a 0 shape, the same way you can't actually physically take apart the pieces.
Oh, so you're not saying that 0 is a shape,
No.
it's shape. Okay.
This is
Thank
going, this was the kind of the hypothetical, the abstract part of it, if you weren't
Gotcha.
just talking about the shapes. If you were talking about just, instead of saying this was shape 1, if that was
So
number
if you were
1.
teaching algebra and you had already done a lot of these with the physical, and you're now ready to not do the physical and you're talking about just the functions, then you can back those up to shape 0 and whatever value that is. That is not something you would do if you're not teaching an algebra concept, if you're in 5th grade, 6th grade, and you're working just with trying to get them to find the patterns. Just trying to get them to find the patterns. They went overhead, I mean, not overhead, but beyond that, because they do teach algebra, so they're.
I was just making sure he wasn't saying that 0 was a shape.
Nope,
The way
Shape
the worded
0.
came out. We know it's a number.
that's why
Okay,
I said hypothetical.
so, read your sentence to us.
Oh, sure, the sentence that we use is, we came up with the number of blue squares in the shape is equal to 4 times the shape number plus 1.
The number of blue tiles or whatever in the shape is equal to 4 times the shape number plus 1. Is that very clear, or are we thinking we're multiplying that plus 1 times the 4?
It could
There's a comma, there's a comma.
Read it again.
Sure, the number of blue squares is equal to 4 times the shape number plus 1.
So it depends on how he reads it. 4 times the shape number plus 1?
No, because there's a comma.
Yeah.
There is a comma.
And it also depends on how you read it.
And,
If the kids can see the comma, and I can't, of course, I don't have my glasses on, then that's
And
fine.
you use the comma.
But how could you rephrase that so it's clearer that you're not multiplying that 4 times that 1?
The sum of, like,
Finish it, because I can't read your mind. Finish it. The sum of,
the sum of 4 times the shape number plus 1.
you
Because
got
then
that?
your note, the sum is those two things added.
Yes, because then they're concentrating on the sum. Okay, all right.
See, one of the things I was thinking of when you were first telling the first group about it, when it says 4 times the shape number plus 1, the reason I don't see any problem with this part is because of the order of operations. You don't have anything in here that would lead you to believe that there would have to be a parentheses to change the order, and multiplication is going to come before the addition.
If you know your order of operations, or if you remember your order of operations. But I can read that, and I know my order of operations, and I can still read it incorrectly. So you
Right.
have to be very careful with young people,
Yeah.
because if they do know the order of operations, they don't know it well enough.
Right.
It is a 5th grade teacher's problem, but 8th
Yeah.
graders.
Oh yeah, they all. Oh yeah.
Yeah.
Mine were real fun with that last year.
So I want you to just look, their function was f of x equals 4x plus 1. Their function was y equals 8x minus 4. Same shape, right? Different function because they're concentrating on different colors, which is what you want to happen in your classroom. If you're gonna give this pattern to more than one group, if they're not gonna pick correctly, you pick 4 of them, say you do the red, you do the blue, you do the total. Okay? All right, very nice, very good.
One thing I was going to add is, we did this little part on here to actually have the names, so the blue squares is equal to 4, and then inside the parentheses there for the multiplication was the shape number plus 1, just to
Good.
add that other part in there. So
Very
you can
good.
actually tie it to the colors and the shapes.
Okay, and they did connect the dots because they did want to carry it on further to the function level. Did I skip one? Okay, let's do that one. Oh, thank you.
I'll stand up there with you.
She's so
I'm gonna
brave.
stand back here actually, so.
There's not enough room.
All right, so, Johnny is with me and my principal. Oh, sure, thank you.
Ivana.
Ivana.
She can go back.
Okay, so, in the top left-hand corner, we have the drawings. Those are the initial drawings that we were given.
Well, we were doing number
7.
Number 7.
Those were the initial drawings, with some additions. On that largest T, where Johnny's actually pointing now, we added a couple of tiles to that drawing because there was not enough room for an actual 4th drawing on this paper. We had drawn it on a sheet of paper, to figure it out. So we added it on here and probably should have used separate colors to show what we added.
That's okay.
Number 7. On the right-hand corner, we have our coordinates. Okay, so the X values are indicative of the figure 1, figure 2, figure 3,
Okay,
and figure 4, and we took it down several to make sure that the pattern would work.
okay,
Our Y values then are indicative of the number of tiles that we had within each shape as a total number of tiles. Once we got our table, then as a group, we started working to see what our pattern actually was. And I'm trying to see because I don't remember. 4, 9, 7,
Those are hard for me.
and some number 16 and 19.
13.
Thank you. Okay, so based on that, we figured out that for each successive figure, we added 3 tiles. Okay, so we figured those 3, it would be an addition of 3 tiles for each successive figure.
mhm,
Okay, so before we did the graph, we actually went and wrote what our function would be.
okay,
Not necessarily the description, just the function, which is y is equal to 3x plus 1. We tested it out with a 0 as a figure of being a 0. However, we did not put it up there because our discussion then led into, well, do we really have a 0 figure? Can we really call it that? And so we decided to leave it off, even though we did kind of go there a little.
well, according to your data, you don't have one.
Right, so we just talked about it but left it off because it wasn't accurate to what we were, or what my principal and I were thinking, because Johnny was real good. She would pipe in there every once in a while and kind of sit and let it percolate and ask some good questions, but she would really let he and I work together. Now, on our graph, yes, you do see it plotted. However,
See what plotted,
you see our coordinates from our table plotted.
okay,
However, we connected the line because I believe Moira was the one who said we didn't know that you didn't have to connect the lines. I think from a scientific perspective, at least for me, I'm always seeing those plotted and that there's a line or a parabola or, you know,
Frequently.
hyperbola or whatever. I always see something connected. So we connected it automatically. The discussion as to whether or not it should have been connected or not happened after, and so it should not have been because it's a discrete number, or
Very
discrete
good.
data.
very good.
Okay, and I cannot read from this direct, from
Read
here.
the sentence,
Can
Johnny.
you read what it says?
It says each successive figure requires 3 times the number of the figure in the sequence plus 1.
Okay, read that again.
The successive figure requires 3 times the number of the figure in the sequence plus 1.
Okay, so is that plain enough that you're not multiplying that 3 times that 1? The way that one is phrased, it's very plain, very plain. So, good job, okay. What I want to look at now, I think Sean brought this up, almost all of these, or maybe all of them, had a plus or a minus after that, okay? So if we extended these, would they have gone through the origin? I mean, picture in your mind your graph being extended. They would not have. So these are not proportional relationships. If they were proportional relationships, they would not have a plus or a minus. It would just be y equals kx. Okay? So in your algebra books, for some reason, when it's y equals kx, they use a k, but when it's y equals mx plus b, they use an m. And the k and the m are really the same thing, okay? So they use a k standing for constant of proportionality, they use an m standing for slope. All right, you know why they use m for slope, Mr. Martin? What does it stand for, Martin?
No, I'm just thinking about how they use the C first for the intercept and then they use B for intercept.
Yes, they do, they do. So what I want you to look at now, what I want you to look at now, we're not gonna have time to do the TEKS, we've got maybe 15 minutes. I want you to look at your picture, your drawing, and this, y'all listening?
Yes.
This group right here explained that they took off the two that make the Z because those stayed the same. And those two are the two here in their function, not that two, this two. So that's a constant. That stayed the same for every one of them. This is what changed. The x times x plus 2 parentheses changed, plus 2 constant. So at with your group or by yourself or something, I want you to look at the pictures. I'll use this one for an example. Look at the picture and tell me, where is that -5 in the picture and where is that 8? You have to be able to relate it back to the picture. Where is that -5 and where is that 8? Okay? So looking at yours, talk to people, even if they're not in your group, and figure that out. Okay?
So we're trying to figure out where the 1 and 1, the 2 and 3, where the pattern is that the 2x, that's the function we're looking for. What is the 2?
Adding to every figure.
Okay, so where is it on here?
In the picture, you're adding 2 every time. I don't know, minus 1 unrelated.
Okay, so y equals 3.
You're doubling, don't look at the top. Look at the oh, minus 3.
So it's really not there. And if we're going to get to the end, it's just a way to.
You're right, but that's what you do for -3, that's Wait, but 11 years. Wait, 3 minus 8, so now what is 11?
So like if you look at when you're looking at these, if every single one of your y values goes up by the exact same amount, that's enough to multiply your x.
3 minus 8 is that.
But I think maybe just the shapes, not but just the shapes, they can find the patterns in the shapes. The table and the function is different.
But you know what, I think they could do all of this.
They could, maybe after doing
I
some of
think
the shapes.
if you started with, very
But
simple.
start with the shape.
And everybody did it together.